Winter light filters through tall factory windows somewhere in the American Midwest. Steel beams hum faintly as machines stand idle, waiting. Drafting tables are clean. Assembly lines are silent. To foreign observers, this stillness looks like weakness. Across the Pacific, in offices lined with technical drawings and slide rules, Japanese engineers study reports from the United States. They see civilian factories, consumer cars, refrigerators, radios. They see a nation wealthy but soft, industrial but undisciplined, capable of quality perhaps, but not speed, not war speed. Their calculations feel reasonable. Japan has built aircraft with precision under constraint. Every rivet matters. Every engine is tuned by hand. War, they believe, is won by skill and efficiency, not excess. Then the war expands, and the silence inside those American factories ends. By 1944, the numbers no longer fit on a single page. They no longer feel theoretical. 18,000 aircraft will roll out in a single month. For the first time, Japanese engineers realize they are not fighting an enemy's army alone. They are fighting an entire system, one they never truly measured. That realization does not arrive all at once. It unfolds slowly as the world that produced those early assumptions begins to collapse. In the years before the Pacific War, industrial strength was measured differently depending on where you stood. In Japan, industry had grown under pressure, limited land, scarce raw materials, and a national memory shaped by isolation. Every factory was designed to conserve. Every engineer was trained to refine. Aircraft production in particular was treated as a craft. Frames were light, tolerances were tight, skilled hands mattered more than volume. Japanese aviation engineers emerged from this system with confidence. Their fighters were admired across the world in the late 1930s. Long range, exceptional maneuverability, efficient engines tuned for performance rather than durability. These were machines designed to win early, decisive battles. They reflected a belief deeply embedded in Japanese military thought. Wars would be short, sharp, and settled by elite forces before industrial exhaustion became decisive. Across the Pacific, the industrial landscape looked very different. The United States was already the world's largest industrial economy, but much of that output served civilian life. Automobiles poured out of Detroit. Household appliances filled catalogs. Steel production dwarfed most nations combined. But it was not optimized for war, not yet. To Japanese observers, this mattered. Intelligence officers and engineers alike saw American factories as large but unfocused. Production lines were spread across dozens of competing companies. Designs changed frequently. Aircraft models were replaced before older ones reached maturity. From a Japanese engineering perspective, it looked inefficient, almost careless. Reports compiled in the late 1930s emphasized this point. American aircraft production numbers lagged behind European powers already mobilized for war. The U.S. Army Air Corps was small. Budgets were politically contested. Isolationist sentiment slowed rearmament. To Tokyo, these were not temporary conditions. They appeared structural. Japanese planners compared their own tightly controlled industrial system with what they perceived as American excess. In Japan, ministries coordinated output. Designs were frozen early. Modifications were incremental. Factories were few, specialized, and protected. Output was limited, but predictable. Engineers trusted numbers they could personally verify. American industry, by contrast, seemed chaotic. Too many companies, too many models, too many civilian priorities. This perception extended beyond aircraft. Shipbuilding, armaments, engines, all appeared subject to political debate rather than national urgency. Even when American factories expanded, Japanese analysts noted that much of the growth was theoretical. Capacity did not always translate to finished weapons. Labor turnover was high. Skilled workers moved between firms. From the outside, it did not look like a machine built for sustained war. There was also cultural bias at play. Japanese engineers valued mastery earned through repetition and discipline. The American emphasis on interchangeable parts and assembly line speed felt crude by comparison. Faster production often meant heavier airframes, less refined aerodynamics, greater fuel consumption. On paper, Japanese fighters could outfly their counterparts. That mattered more than raw output, at least at first. By 1940, as war consumed Europe, Japanese intelligence assessments hardened. The United States was wealthy, yes, but wealth did not equal readiness. Even if America entered the war, engineers believed it would take years to convert that wealth into effective military power, years Japan intended to deny. These assumptions shaped strategy. They influenced aircraft design decisions that prioritized performance over durability. They reinforced the belief that pilot skill could compensate for numerical inferiority. Most importantly, they encouraged a dangerous conclusion that American industry could be outrun. It was a conclusion formed in peacetime, and it would be tested the moment war forced American factories to choose between comfort and survival. That test was coming, and when it arrived, the rules that governed production would begin to change almost overnight. The attack that forced that choice came suddenly, but its effects unfolded with relentless speed. After December 1941, hesitation inside the United States ended. The shock of Pearl Harbor did more than destroy ships and aircraft. It removed political barriers that had restrained industrial mobilization for a decade. What followed was not gradual adjustment, but structural transformation. Within weeks, American factories were reassigned new purposes. Automobile plants received blueprints for bombers. Typewriter manufacturers were handed contracts for machine guns. Refrigerator companies began stamping aircraft parts. This was not improvisation. It was coordination on a scale no modern nation had yet attempted. At the center of this transformation stood the War Production Board. Its authority cut across corporate rivalries and regional interests. Civilian priorities were subordinated to military necessity. Materials were allocated by need, not profit. Designs were standardized. Production bottlenecks were identified and eliminated with ruthless efficiency. American industry did not merely expand. It reorganized itself into a single, interconnected system. Assembly line logic, once reserved for consumer goods, was applied to warfare. Aircraft were broken down into components that could be produced simultaneously across hundreds of plants. Wings in one state, fuselages in another, engines somewhere else entirely. Final assembly became only one step in a vast national process. Labor followed the same logic. Millions entered factories for the first time. Women replaced men who had gone to war. Training programs shortened learning curves. Tasks were simplified, specialized, and repeated. Individual craftsmanship mattered less than consistency. What mattered was throughput. Japanese intelligence struggled to keep pace with this shift. Early reports continued to rely on pre-war benchmarks. Analysts tracked factory numbers without fully understanding integration. A plant producing no finished aircraft might still be feeding dozens of others with parts. Output was no longer visible in a single location. It existed everywhere at once. By 1942, production figures began to rise sharply. American aircraft output doubled, then tripled. New models appeared faster than Japanese engineers believed possible. More alarming still was replacement speed. Aircraft losses that would have crippled another nation were absorbed without visible strain. Japanese engineers noticed the change, but underestimated its trajectory. They assumed early surges would plateau, that quality would decline, that labor shortages or political resistance would intervene. None of that happened. Instead, processes improved, defects dropped, output accelerated. By 1943, the scale had become difficult to ignore. Monthly aircraft production reached levels that exceeded Japan's annual totals. Factories ran day and night. Logistics networks expanded across continents. Even distant Pacific airfields were supplied with replacement aircraft at rates Japanese planners had never imagined. This was no longer a contest of design or skill alone. It was arithmetic. Attrition ceased to favor those who conserved resources. It favored those who could replace losses faster than the enemy could inflict them. For Japanese engineers, the realization was unsettling. Their earlier assumptions had not been irrational, but they had been incomplete. They had measured factories. They had not measured systems. They had counted machines. They had not counted momentum. By the time the pattern became clear, it was already embedded too deeply to stop. What had begun as industrial adaptation was now industrial dominance. And with each passing month, the the numbers widened the gap between what could be built and what could be endured. The implications of that gap would soon be felt not just in production charts, but in the skies above the Pacific. Japanese engineers approached war from the perspective of limitation. Every decision they made was shaped by scarcity, of aluminum, of fuel, of factory space, of trained labor. This bred a mindset where elegance mattered. Aircraft were expected to do more with less. Weight was stripped wherever possible. Armor was sacrificed for range. Components were pushed to their performance limits because there was little margin for replacement. To an engineer trained in this environment, American designs looked wasteful. Thicker skin, heavier frames, engines that favored reliability over finesse. On paper, it felt inefficient. In combat trials before the war, it often was. This belief hardened into professional certainty. Japanese engineers trusted what they could see and touch: a finished aircraft, a pilot's report, a performance curve. They distrusted abstraction. Mass production, especially on the scale the Americans proposed, seemed incompatible with quality. How could tens of thousands of workers, many newly trained, build machines delicate enough for aerial combat? The answer, they believed, was simple. They couldn't. Not without unacceptable compromise. American engineers approached the same problem from the opposite direction. They assumed loss. They planned for damage. They accepted that aircraft would be shot down, worn out, or written off after short service lives. Instead of perfecting individual machines, they perfected processes. Designs were frozen not because they were flawless, but because stability accelerated output. A good aircraft now was better than a better one later. This difference in philosophy defined the industrial war. American factories were not trying to build the best aircraft possible. They were trying to build the most aircraft possible that met a minimum combat standard. Once that threshold was met, everything else became secondary: speed, volume, replacement. Intelligence assessments struggled to capture this distinction. Japanese analysts evaluated American aircraft as isolated objects. They compared climb rates, turn radii, armament loads. In those terms, early American fighters often underperformed. What the reports could not easily measure was what happened after combat: how quickly losses were replaced, how fast new squadrons formed, how rapidly pilots were reassigned to fresh machines. By mid-1942, this blind spot began to matter. Japanese units reported facing unfamiliar aircraft types at increasing frequency. The machines were not always superior in performance, but they were present in numbers that felt disproportionate to recent losses inflicted. Aircraft destroyed one week seemed replaced the next. Pilots began to notice something unsettling. Victories no longer reduced enemy pressure. Leadership compounded the issue. Japanese procurement was divided between rival services. The Army and Navy pursued separate aircraft programs, separate engines, separate supply chains. Standardization was minimal. Production runs were shorter. Modifications were frequent. Each change slowed output, but engineers accepted the delay in exchange for incremental performance gains. American leadership did the opposite. Redundancy was embraced. Multiple firms built the same aircraft. Designs were shared. Parts were interchangeable across plants thousands of miles apart. When bottlenecks appeared, production shifted rather than stalled. No single factory was indispensable. No single engineer irreplaceable. The result was not immediately visible from the cockpit. It became visible over time, through exhaustion. Japanese pilots flew more missions on fewer aircraft. Maintenance crews cannibalized damaged planes to keep others flying. Engines were pushed past recommended limits. Losses that once felt manageable began to accumulate. By the end of 1943, the contrast was stark. One side fought to preserve machines. The other treated machines as expendable tools. One side guarded its skilled labor. The other multiplied it. This divergence did not yet feel like defeat, but it felt like imbalance. And imbalance, once noticed, has a way of accelerating. By 1943, the consequences of leadership choices were no longer theoretical. They were visible in hangars, in training pipelines, and in the air itself. Japanese aviation leadership had built its doctrine around the idea that superior pilots flying superior machines could offset numerical disadvantage. That doctrine required time to train, time to refine designs, time to recover losses. American production was removing that time from the equation. Inside Japan, aircraft programs were increasingly shaped by compromise. Rival bureaus argued over priorities. Engineers proposed improvements, but factories lacked the capacity to implement them at scale. Even when promising designs emerged, production runs were small. Each new variant disrupted tooling. Each change slowed output. The system prized advancement, but the war demanded continuity. Across the Pacific, American leadership enforced a different discipline. Once an aircraft met operational requirements, it stayed in production. Improvements were introduced cautiously, often delayed until they could be applied without interrupting output. The goal was not to chase perfection, but to sustain momentum. When a design worked well enough, it was multiplied relentlessly. This philosophy reshaped the technological balance. American aircraft grew heavier, but also tougher. Armor plating increased. Self-sealing fuel tanks became standard. Engines were derated for longevity rather than peak performance. These choices reduced agility, but improved survivability. Aircraft returned from missions damaged but repairable. Pilots lived to fly again. Japanese engineers understood the trade-off. They simply lacked the resources to make it. Adding armor meant reducing range. Increasing durability meant sacrificing climb and maneuverability. Every improvement required something else to be given up. In a system already operating at the edge of material limits, there was little room to adapt. The human dimension deepened the gap. American training pipelines expanded alongside production. New pilots entered service in parallel with new aircraft. Losses were replaced in both machines and men. Experience accumulated unevenly, but numbers stabilized. Japanese pilot training, by contrast, remained lengthy and selective. Early war aces could not be replaced quickly. When they fell, they took years of experience with them. By 1944, Japanese units were flying aircraft that were still dangerous, still capable, but increasingly isolated. They faced formations that regenerated faster than they could be reduced. Attrition no longer punished recklessness alone, it punished exposure itself. The industrial math had turned strategic. Every sortie cost Japan something it could not easily replace. Every sortie cost the United States something it could. That difference reshaped behavior. Japanese planners became cautious where once they had been aggressive. American commanders became aggressive where once they had been cautious. Technology, leadership, labor, and doctrine converged into a single outcome. Air power was no longer about winning individual engagements. It was about sustaining pressure until resistance eroded. Japanese engineers had built machines for decisive moments. American industry had built a system for endurance. By the time this distinction was fully understood, it no longer mattered whether it was fair or efficient. It was already decisive. The industrial engine that had once seemed unfocused was now producing certainty at scale. That certainty would crystallize in a single year when production figures stopped being abstract projections and became an unavoidable reality measured in thousands, month after month. The turning point did not arrive with a single battle or a single announcement. It arrived in ledgers, shipping manifests, and internal reports that grew thicker with every passing month. In early 1943, Japanese technical bureaus began receiving revised estimates of American aircraft output. The numbers were higher than expected, but still framed as temporary surges, emergency production, wartime enthusiasm, something that would surely slow. It did not. By spring, American factories were producing aircraft faster than Japanese intelligence could catalog them. New plants came online without ceremony. Existing ones expanded without pause. Production no longer followed seasonal rhythms or fiscal cycles. It followed demand, and demand only increased. Aircraft types multiplied across roles: fighters, bombers, transports, each feeding a different arm of the same system. For Japanese engineers, the problem was not disbelief, it was scale. They understood growth. What they struggled to grasp was acceleration. Each month's increase did not simply add to the last. It built upon it. Tooling improved. Workers gained experience. Supply chains shortened. Output curves steepened. By mid-1943, American monthly aircraft production exceeded what Japan could produce in an entire year. This was no longer a gap. It was a gulf. And it manifested operationally with alarming clarity. Air losses that should have weakened American squadrons did not. New units appeared faster than intelligence could track. Aircraft destroyed in combat were replaced before their absence could be exploited. Japanese engineers recalculated. They revisited assumptions about durability, pilot survivability, and maintenance cycles. The conclusions were stark. Even if Japanese aircraft outperformed their counterparts in individual engagements, the exchange rate no longer mattered. Victory in the air depended on replacement speed, and replacement speed depended on factories Japan did not possess. Internal memoranda began to shift in tone. Where earlier assessments emphasized qualitative superiority, newer ones acknowledged quantitative inevitability. Some engineers argued for radical simplification, cheaper aircraft, faster assembly, reduced training requirements. Others resisted, warning that lowering standards would erode the very advantages Japanese aviation still held. The debate was unresolved because neither option solved the core problem. American production, meanwhile, continued to absorb shock without slowing. Strategic bombing campaigns expanded. Long-range escort fighters appeared in growing numbers. Aircraft carriers replenished their air wings between operations with unsettling efficiency. Losses were anticipated, budgeted, and replaced. By late 1943, the war in the air had changed character. Japanese pilots no longer fought to thin the enemy. They fought to delay him. Every engagement bought time, but time itself had become the enemy. The longer the war lasted, the stronger American air power grew. Factories thousands of miles from the front were now shaping battles before they were fought. The outcome of future engagements could be inferred from production schedules months in advance. For the first time, Japanese engineers confronted a reality they could not redesign their way out of. And still, the worst was yet to come. The figures that would arrive in 1944 would not merely confirm the trend, they would end the debate entirely, reducing the war to a question no aircraft design could answer. In 1944, the numbers stopped being estimates and became declarations. American aircraft production reached a rhythm that no longer fluctuated with crises or campaigns. It ran continuously, month after month, with a consistency that stunned those still tracking it from the other side of the Pacific. That year, American factories produced aircraft at a rate approaching 18,000 per month. This was not a spike, it was sustained output. Fighters rolled off lines in such volume that losses at the front barely registered in the totals. Bombers were delivered faster than crews could be trained to fly them. Transport aircraft filled the skies behind the front, turning logistics into momentum. Every category expanded at once, feeding a war machine that no longer needed to pause to reorganize. For Japanese engineers, this was the moment when abstraction collapsed into certainty. The debate inside technical bureaus ended quietly. There were no dramatic announcements, no formal acknowledgments of error. The figures themselves were sufficient. Even the most optimistic projections could not close the gap. Even radical redesigns could not compress time enough to matter. Factories in Japan were now working at their limits. Air raids disrupted output. Raw materials arrived late or not at all. Skilled labor was irreplaceable and increasingly scarce. Production schedules slipped, then fractured. Where American factories absorbed damage and rerouted output, Japanese plants stalled. Each loss echoed forward. In the air, the consequences were immediate. New American aircraft types appeared in overwhelming numbers. Long-range escorts erased the sanctuary Japanese defenders had relied upon. Bombers returned again and again, regardless of losses. Airfields destroyed in the morning were operational again by nightfall, supplied from an industrial base untouched by the fighting. Japanese pilots noticed the change before the engineers fully processed it. They faced waves that did not thin. Aircraft shot down were replaced within days. Formations returned larger than before. The sky itself seemed inexhaustible. By mid-1944, the imbalance dictated strategy. American commanders planned operations knowing replacement was guaranteed. Risk became acceptable. Aggression became routine. Japanese planners, by contrast, measured every sortie against dwindling reserves. Each mission carried weight beyond its tactical outcome. Every loss narrowed the future. The war had reached a point where performance no longer defined advantage. Numbers did. Reliability did. Endurance did. The American system had transformed production into a weapon as decisive as any aircraft it built. For Japanese engineers, the realization was final. They had not misjudged American ingenuity. They had misjudged American capacity for scale. They had measured factories when they should have measured networks. They had evaluated machines when the true weapon was momentum. By the end of 1944, the outcome in the air was no longer uncertain. It was arithmetic. And arithmetic, once it reaches this scale, offers no compromise. What followed would not reverse the imbalance. It would only reveal its consequences, written across battlefields, cities, and the final trajectory of the war. The consequences unfolded with a quiet inevitability. By the time American production reached its peak, the strategic balance in the Pacific had already tipped beyond recovery. Air superiority was no longer contested in equal terms. It was imposed. Japanese aircraft still rose to meet incoming formations, but each interception carried a cost that could not be absorbed. Losses accumulated faster than replacements. Pilots were rushed into combat with fewer hours in the air. Aircraft were flown longer, repaired more often, and retired later than intended. Maintenance crews worked with diminishing supplies, improvising where once they followed precise specifications. The margin for error narrowed until it disappeared entirely. American air power, by contrast, expanded its reach. New bases appeared across the Pacific, each supplied by a logistics network that extended back to factories operating beyond enemy reach. Aircraft carriers replenished air wings between operations. Strategic bombers operated with increasing freedom, supported by escorts whose numbers guaranteed coverage from takeoff to target. Japanese reports from late 1944 reflect this shift in tone, where earlier documents emphasized tactical analysis, later ones focused on sustainability. Questions were no longer about how to win engagements, but how long resistance could be maintained. Engineers documented shortages. Commanders requested delays. Production schedules became aspirational rather than binding. The human cost followed naturally. Veteran pilots, those trained before the war, became rare. Their absence was felt not only in combat effectiveness, but in morale. New pilots flew alongside machines they barely understood, against enemies who returned in ever greater numbers. Survival became exceptional rather than expected. Cities felt the impact as well. As American bombers increased their range and frequency, industrial centers came under sustained attack. Factories already strained by material shortages now faced physical destruction. Output fell further. Repairs lagged. Evacuation dispersed skilled workers who could not easily be replaced. For American planners, the industrial advantage allowed a different kind of calculation. Campaigns could be planned months in advance with confidence that air cover would be available. Loss projections were integrated into production schedules. War became a process measured and resourced rather than gambled. By early 1945, the imbalance had hardened into certainty. The air war was no longer a contest of skill or bravery. It was an expression of capacity. The side that could build faster, train faster, and replace faster dictated the tempo. The other side reacted. Japanese engineers understood this, even as they continued working. There was no illusion of reversal, only obligation. Factories ran when they could. Designs were simplified where possible. Nothing closed the gap. The system they faced was too large, too integrated, too distant from the battlefields to disrupt. The aftermath was not marked by a single collapse, but by erosion. Each month reduced options. Each loss narrowed the future. The industrial war had been decided long before the final battles were fought. And as the war drew toward its end, one lesson remained unavoidable, one that would shape how future conflicts were planned and understood. As the war moved into its final phase, the disparity in industrial capacity dictated not only outcomes, but behavior. Japanese commanders adjusted strategy to preserve what little remained. Air operations became increasingly defensive. Aircraft were held back for critical moments that never truly arrived. The hope was no longer to dominate the sky, but to survive beneath it. Production figures from Japan in 1945 tell a story of contraction. Air raids interrupted power and transport. Raw materials failed to arrive. Factories dispersed into smaller workshops to reduce vulnerability, sacrificing efficiency for survival. Output continued, but at a fraction of earlier levels. Each aircraft completed felt less like reinforcement and more like delay. American production, meanwhile, did not need to escalate further, it simply sustained. The industrial engine that had reached its peak in 1944 maintained pressure without strain. New aircraft replaced old ones, crews rotated, training continued uninterrupted. Even as the war approached its conclusion, factories kept running, their momentum detached from the immediacy of the front. The psychological effect of this imbalance was profound. Japanese planners faced a future where every decision reduced available options. American planners faced a future where options expanded. This asymmetry shaped negotiations, tactics, and expectations. The war was no longer about seizing advantage. It was about managing decline on one side and managing abundance on the other. When the conflict ended, post-war analyses inside Japan confronted uncomfortable conclusions. Technical skill had not been enough. Superior early designs had not compensated for limited output. Precision had lost to persistence. Engineers who had once dismissed American industry now studied it with a different lens, not as a collection of factories, but as a coordinated national instrument. The lesson extended beyond aircraft. It reshaped how nations understood modern war. Industrial systems were no longer background infrastructure. They were frontline weapons. The ability to mobilize labor, standardize design, and sustain production under pressure became as decisive as any battlefield maneuver. For the United States, the experience confirmed a new identity. The country emerged not only as a military power, but as an industrial one capable of sustaining global conflict. For Japan, the war marked the limits of craftsmanship in an era defined by scale. The factories that once seemed slow and unfocused had proven otherwise. They had not won through elegance or refinement. They had won through continuity, through the relentless accumulation of output, until resistance became mathematically impossible. That realization lingered long after the machines fell silent. When the war ended, the factories did not immediately fall silent. Machines that had produced aircraft by the thousands were simply slowed, then redirected. The system that had been built for survival remained, its logic intact. What had changed was the world's understanding of what truly decided modern war. Japanese engineers had not been careless or naive. Their assumptions were grounded in experience, in a tradition that valued mastery and restraint. They believed wars were shaped by quality, by the edge that came from doing more with less. For a time, they were right. Early victories reinforced that belief, but the war they entered did not remain small or controlled. It expanded until it consumed entire societies. American industry did not defeat Japan through a single technological breakthrough or a single decisive engagement. It did so by turning production itself into a strategic weapon. The ability to replace losses without pause removed fear from planning. It allowed commanders to think in terms of pressure rather than preservation. Over time, that pressure became irreversible. The lesson was not that craftsmanship was obsolete. It was that craftsmanship alone could not survive against a system designed for endurance. Precision mattered, but only within a framework that could sustain it. Skill mattered, but only when backed by numbers that ensured continuity. In 1944, when 18,000 aircraft rolled out in a single month, the outcome of the air war was no longer determined in the sky. It was determined on factory floors, far from danger. That shift reshaped history. It defined the post-war balance of power. It changed how nations planned, prepared, and fought. Modern conflict became less about decisive moments and more about sustained capability. In the end, the greatest miscalculation was not underestimating American technology or resolve. It was underestimating scale, how quickly a society could reorganize itself, how completely it could commit, and how relentlessly it could produce. Wars may be fought by soldiers and pilots, but they are decided by systems. And once that truth became clear, the war's final outcome was already written.